Good morning. I want to give you some help for the Using Buffers lab. And the very last question, I think it's number 6. And it's talking about you've got a buffer solution, which means you have a weak acid and its conjugate. Okay, it cannot be a strong acid. It must be a weak acid. And the reason it can't be a strong acid is because, don't forget, a strong acid completely dissociates. And when you have a strong acid, it dissociates completely into those hydrogen ions. Okay, so you've got the solution, and it's got a pH of 5.27. But, you're required to have a pH of 5.27. Okay, so you have a solution with 0.01 moles of acetic acid. And so we want to know what molarity do you need to add to the solution. All right, so you've got this equation called the Henderson-Hasselbalch equation that kind of is a shortcut to all the calculations that you would need to do. So basically, you have the pH that you want. You want this, okay? You know the pH of the acetic acid that you have, and when you take the negative log of that pH, you've got the pKa. And you don't need to worry too much about that, but that's where your 4.7 comes from. So this is what you have. You have this, all right? And then you know the concentration. When you see brackets, that means concentration. And you know the concentration of your initial acid. This is what you are looking for. You are looking for the concentration of the conjugate base. So here's your acid. I want to put that down in a different color. This is the concentration of your initial acid. This is the concentration of the conjugate base that you want. Okay, and that could be, for acetic acid, that could be sodium acetate, lithium acetate, couldn't be magnesium, any group 1 metal with acetate. And you're going to use that as your conjugate base. Okay, so let's start filling in the numbers. So you want to have, you want this, let me get that. So 5.27 is the pH you want. And we know that for the pKa that you have is 4.74. And then we have the log of whatever it is you need to have here and the log of your acid. All right? So I think where people are having a little bit of trouble is you want to have 5.27, come on, minus 4.74, whatever that is. And that gives you the log x over log of 0.01, which you can figure out on your calculator. So you'll want to get this number here, multiply it by this, okay? And then that will give you, use your graphing calculator, and that should lead you to what this answer is going to be, all right? So try that, and that should get you to the correct answer. I hope that this helps a little bit. And you might need to review your laws of logarithms a little tiny bit. I probably spelled that wrong, but that's all over the internet. You should be able to find that somewhere. If you need to review logs, but don't forget your calculator does all that for you, so it shouldn't be too bad.